So looking at these two problems here, the first one, we're given a point and we're given a slope. Now automatically, that makes me think about point-slope form. So if I were going to be writing the equation in point-slope form, it would be y, and then remember it's always y minus the y-coordinate? Well, the y-coordinate here is -2. Y minus a -2 then gives me y plus 2. We're flipping the signs. Another way to think about it is, this -2 here represents a shift down 2. And remember, on the y side, that's a y plus 2. And then the slope is 5, and then it's x minus the x-coordinate, so that's going to be minus a -4, so that's going to be x plus 4. If I were writing the equation in point-slope form, this would be my answer. However, you'll notice this problem specified to write it in slope-intercept form. So this is actually not going to be my answer. But it's a great way to start toward the answer. This is actually one of the best uses of point-slope form, and partly why I actually teach it. Because when you're given a point and given a slope, we'll typically write our answer in slope-intercept form, but writing it this way first allows you to get there nice and easy. Because, in order to figure this out, I'm going to distribute into 5, so I get a 5x plus a 20. And then I subtract the 2 from both sides. Yes, we do need to show our algebra, show -2 on both sides. So we end up with y equals 5x plus 18. That's the final answer we come up with. That is slope-intercept form. Yes, you need to know the names of these things. Hopefully it's not too hard to remember though, because point-slope form, you notice the equation includes a point and the slope. Slope-intercept form includes the slope and the intercept. The y-intercept in that case. And so the names go with what they tell us to try to make them easier to remember. That's going to change a little bit on a new one I'm adding today, though, unfortunately. Okay, so then this last equation here, we got 3x plus 2y equals 18. Kind of an unusual form, right? But this form actually comes up quite a lot when we write equations on our own. So if we're given a situation, we know if I make this many of this product and this many of this product, this is how much money I'll make. That kind of story problem. Oftentimes, those types of problems end up with equations that look like this. So this is actually going to be our focus for today, is seeing how do we deal with equations like that. The first thing we can see is how do I turn it into slope-intercept form? Well, remember slope-intercept, that's our y equals form. And so I'm basically solving this for y. Step 1, subtract that 3x from both sides. So we have 2y equals -3x plus 18. Now I chose to write the x term first. You don't have to, but in slope-intercept form, we've just always tend to put the slope with the x first. It's just kind of what we're used to doing, so I'm going to keep doing it that way. And then I still want to get the y by itself, so that means I'm going to divide both sides by 2. On the left side, of course, that gives us y. On the right-hand side, I'm dividing by 2. Now, I could write my answer as -3x plus 18 all over 2. That is algebraically valid. However, it's not really slope-intercept form, is it? Because I want to be able to just read off out of this equation what is the slope and what is the y-intercept. And so I'm actually going to divide each of these terms by the 2. So this -3x over 2, that's going to become -3 over 2x. Okay, then I repeat the same thing with the plus 18 over 2. 18 over 2 is 9, so it ends up being a plus 9. And then that is our final answer. That is now slope-intercept form. Now a little bit of an addition to your notes. That form that we just solved is called standard form. Now already in your notes, I hope, is all of this stuff. These are notes that we took down last week. But we're adding one more form of a line, and that is standard form. So you're adding this now into your notes. And then with that in your notes, just one little small explanation here. Notice it says standard form of a linear equation is this. The fact that this is linear is important. There's actually multiple types of equations in math that are called standard form. In fact, we're going to be learning about another standard form later this year. It'll be standard polynomial form. So this is considered standard form when we're working with a line, and just with lines. Later on, we're going to see a different one. I don't want those getting mixed up, because that can happen. So having seen standard form and what that means, what it looks like, we're now going to be graphing standard form. So please write this equation down above your first graphing grid. And if we're going to be graphing this, what do you think your first step would be? Yeah, an excellent way to go about doing this, because of the way it's set up and what we know already, is move that 2x over. So I would subtract 2x from both sides of the equation. When I do that, I end up automatically at that point in slope-intercept form, which I already know how to graph. So go ahead, real quick here, make that graph, please. And so, in order to make this graph, we end up starting at a y-intercept of 12. Now that's slightly awkward, right? That's a pretty big number. We're going to see how we can get around having to do this here in a minute. But for now, yeah, we can go ahead and go up to 12 and we can put a point there. And then our slope is -2. We deal with the slope like we always do. That means down 2 over 1, down 2 over 1, and keep doing it until you can draw the line in accurately. So this is what we end up with here. All right. Doable, right? Sometimes, though, when we see these equations, they aren't quite as pretty. Go ahead and write down this equation above your next graphing grid, please. All right, and so our first instinct when we see this, because of what we do know already, is to solve this for y and turn it into slope-intercept form again. But if we did all of that algebra, we would end up with y equals a -0.4x plus 2.4. Technically, we can graph that. However, practically speaking, that's a bit messy to try to deal with. We don't really want to have to mess around with that. And so what we're going to be learning today is a different method that we can use, a method that is specific to the standard form equations. What we're going to do is we're actually going to find a couple points that are on this line. Two very specific points. Why these 2 points? Because they're the easiest two to find. So what we're going to do is we are going to figure out what can I put here that would give me a y-coordinate of 0. Well, if we wanted to figure that out, we could actually solve that algebraically. And so you want to write out this work as we go through it so that you can remind yourself how we did this. Probably off to the side, I got to write it on the grid because that's all the room I have. All right, so if I want to know what makes the y-coordinate 0 like this, I'm going to go to my equation and I am going to simply plug 0 in for y. That will result in whatever x makes y be 0. So we can now solve this. So 5 times 0 is 0. That's why I like to use these points, because that term just went away. I don't have to do an extra algebraic step. All I have to actually figure out is what makes 2x equal 12. And so we divide both sides by 2, and you find that x equals 6. So that tells me then that I have a point at 6, 0. That point must be on my graph, so I can go ahead and plot that point. So I plot a point here, over here at 6, 0. I repeat the process for the other point here. So I want to figure out what is going to make us have a point with an x-coordinate of 0. And so I go 2 times 0 plus 5y equals 12. And I solve that. And notice again, by plugging in 0, really all I'm doing is saying 5y equals 12 and solving that. Now when I do that, I end up with y equals, let's see, what would that be, 2.4? Yes, it's a decimal. But now we only have one decimal. I don't have a slope that's awkward to go with the awkward point. And so I can go ahead and plot that point as well. Now this is a line, right? We know it's a line because it's just plain old y, plain old x. There's nothing fancy in there like absolute values. There's no squareds, there's no square roots. There's nothing else going on with these. Just plain old x, plain old y. And if it's going to be a line, all I need is 2 points, right? So we take those 2 points and we draw the line that goes through them. Definitely want to use a straight edge here. And then that is your final answer. That is your graph for this. And with practice, this actually becomes a very fast method. But it is going to take us putting in the time to practice it. Now to reinforce this process and make sure we have everything down with it, if I were asked to graph these 3 equations, I'd find the x-intercept and the y-intercept. And so that's what I'm going to have you do here. Because notice, the x-intercept is just a point, and if it's going to be the x-intercept, in other words, it's hitting the x-axis, which coordinate is 0 there? The x-coordinate or the y-coordinate being 0? Well, it's not up at all, right? It's at a height of 0 on the x-axis. Hence, our y-coordinate here will be 0. That's what we'll do for x-intercept. For the y-intercept, same idea. Except for the y-intercept, your x will be 0. And your y-coordinate will be, well, whatever we find algebraically. Do that algebra to find out what those other points are, what those other numbers are in our points for this first one and for the remaining 2 after it. There's our answer for our first problem, so you can check it and make sure you're on the right track. Keep going from there. There's the answer for the second one. I chose to write it as negative 1.5. If you prefer negative 1.5, that's perfectly fine. It's up to you. Alright, and there's our last answer. So you can check and make sure that you're on the right track. In every single one of these cases, whichever one is 0, we're just plugging that 0 in for whichever coordinate it represents. So when it's in the y spot, we plug it in for y, solve for x. When it's in the x spot, we plug it in for x, solve for y. Every single time, same method, same process. Alright, and so for our third and final graph that we're going to be doing today, we're going to be graphing this inequality. Now, what's the inequality change compared to the equation? Well, basically nothing until the very end. And so, we're still going to start it the same way that we started the previous ones. That is, you're going to find the x-intercept, you're going to find the y-intercept. So, start by doing so, please. And so I know that for the x-intercept, I'm plugging 0 in for y, solving from there. And when I say solving, basically we want to know where it actually hits that. And so when we plug in 0 and solve it, go ahead and just treat it as an equation. You don't need to keep the inequality when we're doing this at the moment, because we are looking to see when is it equal, because we're looking for the point that's on the line here. You should find that your x-intercept happens when x equals 5, so we have the point 5, 0. Repeat the process to find your y-intercept. And then you should find that your y-intercept happens at the point 0, negative 4.5. And so then, if I'm going to graph this, the very first thing I would do is plot those 2 points. So we go to the point 5, 0, and we go to the point 0, negative 4.5. Plot those points, break out your straight edge, draw the line that goes through them. But then that just leaves us with a question here. Where do we shade? Because, of course, this is now that extra step. Because if it was just equals, that'd be done. But this is less than or equal to. By the way, side note, notice it's or equal to, so I drew the solid line. If it was just less than, would have been dotted. Same rules as normal with that. But we do have one thing that's a little bit different in this case. You may recall I gave you some rules before, even formatted as that little table where we had what would make a solid line, what would make a dotted line, and whether we'd shade above or below. And we saw in that kind of work that a less than symbol, like we have here, would always shade below the graph. But you may also recall that I gave you one little detail in that work. And that was only when y was by itself on the left side. Y is not by itself on the left side here, though. It's on the left, but it's not by itself. So how do we know where to shade? It's a little bit trickier here. We've got to do one more piece of work. What I want to do is I want to figure out whether I should shade above it or below it by testing a point. Now, it doesn't matter which point you choose. So, for instance, let's say I plugged in this point up here. If I plug that in for x and y in the original inequality, if it is true, that means that that point should be shaded. If that point should be shaded, every point on that same side will be shaded. Because, of course, I can't shade that point, but have other points over here that are shaded, right? It has to be everything on one side or the other. So we're just going to choose any point we want to plug into this. And so, for this first one, I'm going to choose an arbitrary point. I'm going to choose one that's maybe nice, easy numbers to work with. I'm going to choose, for the fun of it, the point 2, 1. So, I'm going to take the point 2, 1 here, and I'm going to plug it into my original inequality. So that means I'm going to be doing 9 times 2 minus 10 times 1 is less than or equal to 45. And what we're trying to figure out is that a true statement? So that means I got to do the work on the left-hand side. So I do 9 times 2, that's going to give me 18, minus 10 times 1, which is 10. 18 minus 10 gives me 8. So I have 8 is less than or equal to 45. Is that a true statement? Yes, it is. Because that is a true statement, that tells me that I should be shading that point. If I should be shading that point, I should be shading every point on that same side. So I'm going to be shading everything that is above my line in this case. If it were not true, I would have shaded the other side. Now, one last little note about that process. I chose an arbitrary point of 2, 1 when I tested it. Is there maybe a point that you would have found easier? What do you think the easiest point you might have chosen would be? Different people have different ones. Some people say 0, 0. Some people say 1, 1. Go with whichever one seems easiest to you. For me, that was always 0, 0. But some people get that mixed up with the whole process about putting the zeros in up here. And so that's not a good idea as a way to remember it. And so the key is just remembering that you can choose any point on either side. It just has to be on the side of the line. It can't be on the line. Otherwise, it'll definitely be equal. And so having seen that process, graphing from standard form is kind of its own unique little beast, as you've seen here. So this is a step-by-step process of what we just did in order to graph from standard form. Please add this into your notes.